Hey there, so let's have a look at question 4 of this mock 5 of paper 2. So in this question, it's telling us figure 1 shows a semicircle with center O and radius 8 centimeter. The chord PQ and the radius OQ divide the semicircle into 3 regions. The regions are the area A1, A2 and A3 are shown in figure 1. Given that the angle POQ is equal to theta radians, show that A1 can be written as K times theta minus sine theta, where K is a positive constant to be found. So this question looks a little bit more difficult than it actually is. It's actually quite straightforward. So in this case, let's try to break it down. So how can you find A1? In order to find A1, we need to find two things before that, which I'm going to highlight here. That first of all, we need to find the area of this sector here. And once you find the area of this sector here, from there, we need to subtract the area of this triangle here. So in a moment, I will show you both formulas and how they work. And by subtracting the area of the sector from the area of the triangle, that will leave us with A1, which is that section there. So the area of the sector can be calculated by doing the following. A half r squared theta. So this is the formula that we can use. We can use this formula in this case here, given that our angle is in radians. So, and the area of the triangle can be calculated by doing area, let's write it here, area of triangle can be calculated by using a half AB sine C. So let's try to calculate it, both of them together. So let's also rewrite this area of sector is equal to a half r squared theta. So the area of the sector in this case here, that would be a half times my radius, which is 8 squared times theta. So that simplifies down to a half times 64 times theta. That simplifies down to 32 theta, which is my area of a sector. The area of the triangle, on the other hand, again, very similarly, I need to use two sides and the angle in between. So we have the angle as theta, and the two sides, of course, is 8 and also 8 because they are the radius, so they will be equal to each other. So that would be a half times 8 times 8 times sine theta. Again, simplifies down to a half times 64 sine theta, which simplifies down to 32 sine theta. So again, now I've calculated two parts. So we know that if you rewrite in terms of the formula, that A1 plus A2 must equal to the area of the sector. So in this case, if you want to calculate A1 will be the area of sector minus A2. So the area of the sector, we just calculated to be 32 theta. The area of the triangle, which is A2, is equivalent to 32 sine theta. So we're subtracting that. From here, we can see what we can take out. So we can take out a factor of 32. So if you take a factor of 32 out, you're left with theta minus sine theta. And therefore, that will be my final answer in this case here. Okay, that's your part A done and dusted. And therefore, my K is equal to 32. And we can see that's a positive constant. So now, in order to do part B, we need to find A3. A3 again is another sector that we need to find. So let's highlight that out. This is another sector that we're trying to find, which is this one here. The only thing that we are missing from here, again, this is 8 centimeter. So the only thing that we're missing is the angle, but we know that angles in a straight line adds up to 180 degrees, or in terms of radians, that would be pi. So in this case, in order to find that angle, that will be simply pi minus theta, which is the angle of the other sector. So now let's try to find A3. So A3 is going to be equal to, again, area of a sector, which is a half r squared theta. And if we simplify it out, in this case, that becomes a half r squared, which is 8 squared. And theta in this case will be pi minus theta. So that simplifies down to a half times 8 squared, which is 64. Pi minus theta simplifies down to 32 bracket pi minus theta. So that's my A3, which I've calculated right now. So now they're telling me that A3 is equal to twice of A1. So we can equate this that equation, the two area of a sector like this, and then try to find out what my sine theta will be equivalent to, and if you can equate it to the same answer as they got. So my A3, so which is 32 bracket pi minus theta, is equivalent to 2 times my A1. My A1 I just calculated to be as 32 times theta minus sine theta. So if I equate it here, so that becomes 32 pi and minus 32 theta. That's equivalent to 2 times 32, 64. So 64 times theta, that would be 64 theta, and 2 times 32 times minus sine theta, that would be minus 64 sine theta. So once I've expanded my equation, so now I need to simplify and make sine theta the subject. So I can move the 64 theta to the other side, so that become minus 64 theta. So I can rewrite this as 32 pi minus 96 theta. So minus 32 theta minus 64 theta gives us minus 96 theta. That's equivalent to minus 64 sine theta. So from here, I can make my sine theta the subject by dividing both of these elements on the left-hand side by minus 64. So if I do that, sine theta becomes equivalent to 32 pi over minus 64 minus 96 theta over minus 64. So if I simplify this down, so that becomes sine theta is equal to 32 divided by minus 64 is minus 1 over 2 pi, and that becomes minus plus, because minus 96 divided by minus 64 cancel the negative cancels out, and 96 divided by 64 gives us 3 over 2 pi, and therefore this will be our final answer, which we can see is exact match to what they have got as well. All right, perfect. Any questions, do let me know below, but this is part B of question 4. Thank you.